All right, let's talk about the future. And I mean the real future, beyond 5G. We're going to dive into the truly mind-bending world of 6G. And look, this is not just a simple speed boost for your phone. No, no. We're talking about a complete revolution in how our digital and physical worlds connect. And it's all going to be powered by something you see every single day, light. So how could a simple light bulb change literally everything? Let's find out.
Okay, so here's how we're going to break it all down. First, we'll peek into the sci-fi stuff that 6G is promising. Then, we got to understand why we're kind of hitting a wall with our current tech. After that, we'll look at the actual blueprint for 6G and get into the wild idea of sending data through light. We'll also check out the other cool tech in its toolkit, and then finally, we'll ask the big question, are we even ready for all this?
To really get what 6G is all about, you have to start by imagining the world it's being built for. This is so much bigger than just faster downloads. We're talking about enabling experiences that, up until right now, have been pure science fiction. Okay, so picture this. Forget your typical video call. Imagine interacting with a super high-precision, real-time 3D hologram of a person, like they are standing right there in the room with you. Now, to pull that off, you need a ridiculous amount of bandwidth and almost zero lag, something 5G just can't do at a big scale. But for 6G, that's one of the main goals. But what if we could push it even further? What if you could transmit the sense of touch? That's the idea behind the tactile internet. It could let a surgeon guide a robotic arm from thousands of miles away, actually feeling the resistance of tissue as they make an incision. It's about sending physical skills, not just data, over the network. Wild, right? And the ambition here is just massive. It's not just about talking to people in real time. The people designing this stuff imagine us interacting with holographic projections of historical figures. Or picture an architect walking through a full-scale holographic model of a building that hasn't even been built yet. So that begs the question, why can't we do this now? And that brings us right to the heart of the problem. Our current networks, and that includes 5G, are built on a foundation that is basically running out of road. To make holograms and tactile feedback a reality, we need a bigger pipeline, a much, much bigger one. Think of it like this. All of our wireless data is like cars on a highway. The radio frequency spectrum, that's the highway we use for everything from AM radio to Wi-Fi to 5G, is just completely jammed. It's a traffic nightmare. It's crowded, it's regulated, and we are flat out of new lanes to build. But now, look at the optical spectrum. It is thousands of times wider. It's almost completely empty, and it's unlicensed. It's this huge, untapped frontier. So you see, 6G isn't about just adding another lane to that old, crowded highway. Not at all. It's about building an entirely new transportation system, one that's designed from scratch to use that massive, wide-open optical spectrum. It's a total redesign of how we think about wireless. And it makes sense if you look at the history of wireless, right? A new G has popped up roughly every 10 years, and each one unlocked something new. We went from voice to text to mobile data to the Internet of Things with 5G. So 6G, which we're expecting around 2030, is the next logical step, but it's the sheer ambition of creating this tactile, holographic era that makes it so incredibly different. So here's the bottom line. 6G is being engineered from the ground up to solve this spectrum traffic jam by moving into these way higher frequencies. We're talking terahertz and optical bands. That's the secret sauce. That's what unlocks the insane capacity we need for that sci-fi future. So, how in the world do we actually do that? Well, this is where it gets really, really cool. The main technology for tapping into that optical spectrum is called optical wireless communication, or OWC for short. And it all kicks off with a really simple but powerful idea. I mean, seriously, just stop and think about that for a second. What if every single LED light in your house, in your office, even the headlights on your car, what if all of them could also be transmitting data at unbelievable speeds? That's the core idea behind a type of OWC called Li-Fi, which stands for light fidelity. So, at its heart, OWC is simply using light, whether it's visible light, infrared, or even UV, to send data. Basically, by flickering an LED light bulb at speeds so fast the human eye can't possibly see it, you can encode a massive amount of information into that beam of light. So, how does this stack up against the Wi-Fi we all know and love? Well, OWC has incredible speed, and because light doesn't go through walls, it's way more secure by its very nature. Plus, you get zero radio interference. Now, the big trade-off? You need a direct line of sight. If you block the light, you block the signal. Wi-Fi, on the other hand, goes through walls, but it's stuck on that crowded, interference-prone radio spectrum. Now, OWC is an absolute game changer, but it's not the only piece of the puzzle. To build a network that's actually robust, especially one that can get around that whole line of sight issue, engineers are developing an entire ecosystem of brand new technologies that all have to work together perfectly. Yeah, I know, this diagram looks pretty complex, but it really just shows that 6G is a mashup of all these new ideas. See these phrases here? Integration of communications and sensing, and making the network natively intelligent. It's about so much more than just raw speed. So let's just zoom in on two of the key concepts that make all of this possible. Okay, first up, we have reconfigurable intelligent surfaces, or RIS. The simplest way to think about these is like smart mirrors for wireless signals. Imagine painting the walls of a room or covering a billboard with this material. It could grab a 6G signal, light or radio waves, and just bounce it right around a corner to reach your device, completely solving that line of sight problem. Next up is ISAC, and this is where the network itself almost becomes self-aware. With integrated sensing and communication, the very same signal that's delivering your data can also be used to sense the world around it. Your 6G connection could literally map a room in 3D, detect your hand gestures, or track cars for self-driving vehicles, all while it's giving you a connection. And listen, this isn't just stuff on a whiteboard somewhere. Prototypes and testbeds are already out there proving that these concepts actually work. And the results they're getting are, well, they're pretty staggering. Get this. In one test of a 5G advanced ISAC system, which is kind of like a warm-up for 6G, researchers were able to detect vehicles and people over 500 meters away just by using the communication signal itself. That's the power of a network that can actually see. And what about speed? Another prototype, this one using terahertz band ISAC, hit an incredible line-of-sight speed of 240 gigabits per second. To put that in perspective, that's fast enough to download several full high-def movies in a single second. Just wow. So yeah, the potential is just off the charts. But building this hyper-connected future, it's one of the biggest engineering challenges of our generation. There are some major hurdles we still have to get over on the road to 6G. First, we need completely new hardware that can even operate at these insane frequencies. We have to figure out how to manage networks that are this complex and this expensive. And when you have a network that can sense the environment around you, making sure our data is secure and our privacy is protected becomes more important than ever. And of course, we have to make sure this whole new infrastructure is green and energy efficient. And that really brings us to the final question to think about. The whole journey from 1G to 6G has really been about shrinking the distance between us and our information. 6G is poised to take that final step and actually merge our physical and digital worlds. So the question we're left with is this: when that finally happens, what will it truly mean to be connected? Thanks for digging into this with me.